Parallel and perpendicular lines. That's what we're going to be dealing with. So in red, you don't have to write this because I'm just going to start talking. If you need a refresher of what the word parallel means, I could have a line moving in this direction, and I'd put arrows at the end of it to kind of communicate that it goes on forever. And if I had another line moving in the same direction, these distances would always be the same between them. And even millions of miles into the future, this would not happen. These two lines would never run into each other. They would never intersect if they are parallel. So if you have a pair of parallel lines, I could look at one point compared to another and one point compared to another, and its rise over its run, delta y over delta x, for the first line would be the same as the other one. And so what this means is kind of back and forth, like either going to the left or going to the right. If I know that I have equal slopes, I also know that their lines are going to be parallel to each other. And vice versa. If I have parallel lines, I would also know that their slopes would be equal. So let's go ahead and get your ruler out and just draw a line here, moving in an upward angle to the right. And then if you have your ruler, as you've drawn this, which you should, you just kind of cautiously slide your ruler down to maintain a parallel line as you draw this, so that then when you go to draw the next one, you're a little further down and you can try and draw as parallel of a line as possible. And we need to be able to tell these two lines apart, so below here I'll write L1, and below here I'll write L2. Because I'm just communicating that I have two lines written with a lowercase l as a cursive L, L sub 1, L sub 2. So if I have two non-vertical lines that have the same slope, well then that would mean that if m sub 1 equals m sub 2. So it's like I'm saying that the slope of this line is the same as the slope of the other line. So if m sub 1 equals m sub 2, comma, then, so if I draw two long lines and then an arrow on it, this means then in geometry. So if m sub 1 equals m sub 2, then L sub 1 is parallel. Now I don't want to just draw two little lines like that because it might look like an 11. And I also don't want to draw them too spaced apart because it might look like absolute value brackets. So I'll write L sub 1 is parallel to L sub 2 like that. So if m sub 1 is equal to m sub 2, then L sub 1 is parallel to L sub 2. And the reverse is true as well. So technically, we could use a symbol like this, meaning it's bidirectional, going in both directions. Now, the other thing we know is there is a little bit of a need to point this out. Well, vertical lines don't have slope. Their slope is undefined. So if I knew that one line was vertical and another line was vertical, I would also be able to say they're parallel. All vertical lines are parallel. So let's take a look at how we would do a first type of problem here. So write the slope-intercept form. Here's y equals mx plus b. So we've dealt with, how to deal with the slope of a line through a given point, and now we're going to talk about like a parallel line through a given point. So geometrically, this means, well, I know some things about this first line. Maybe I know its slope. And if I know the slope of the first line, then I can tell you what the second one's going to be as well. So rereading the directions, write the slope-intercept form of an equation for the line that passes through -1, -2. So that means that my desired line is going to go through it. But this desired line is also parallel to the graph of y equals -3x minus 2. So over here, let's write m equals, and then as you're looking at a problem in the textbook or whatever, you'd find the slope of one line, which would let you say that m is negative 3. Which tells me that I have at least one thing that I can plug in to this new line. So originally I had 1, 2, 3, 4 letters. I now know one of those. I'm not going to be able to find the y-intercept of my line, and the reason I can't do that is because these lines are located in different spots. So if they're located in different spots, then they would not have the same y-intercept. So that means that the mystery number I'm going to solve for is going to be b. So here I am just writing plus b. But I do know that my new line has to go through the point negative 1, negative 2. So I'll sneak a negative 1 here, and I'll sneak a negative 2 there. So now I have an equation that's rather easy to solve. So b would be negative 5. Well, we know that the new line has to have the slope of the other guy. We figured out what b would be. So when I go to plug these values into y equals mx plus b, for the generic universal case of this line, I'm going to say, well, y is negative 3x plus a negative 5. So I'm just going to jump right into writing subtracted by 5. So that's how you do a parallel line through a given point. You can re-watch this, and you can try to do this one on your own if you'd like, because it's kind of the same, but instead you'll have to use point-slope form. I'm going to walk through this. You can pause it and try it on your own. I'm not going to go crazy fast since this is somewhat new in its presentation. So write the point-slope form of an equation for the line that passes through 4, negative 1. So we know that this new line is going through there. But it also has to be parallel to the graph of y equals 1/4 x. So I know that both lines will have the same slope, and that would have to be 1/4. So when I go and I plug this into my formula, we always like to write the map out first. I know y minus, and I'll jump right in. I'll say, well, there's my y sub 1. I'll write negative 1. It's equal to m, which is 1/4, x minus, and then here's x sub 1, which is 4. Other than having to simplify this plus 1 equals 1/4 x minus 4, we don't have to do anything else, because this is okay being a fraction. It's not like standard form where we have to get rid of fractions and only have integers for a, b, and c. So, as weird as it feels, you're done with that. Now this is only the parallel lines. There's going to be a different rule for perpendicular lines. We also have a different symbol for how we write it. We'll cover that in the next video. And the only thing I'll warn you about is it's easy to read too quickly and ignore the fact that it says perpendicular and end up doing this for a parallel line. So that's the first of the 4 videos for this section.